Hello guys, welcome to one and all to this channel. So today in this video, I'm going to discuss with you about a topic called statistics. So this statistics is basically used in data science to analyze the data and visualize it in a more beautiful way, because having data is not at all enough, because it may be available to us in a form of raw data, which means it may not be helpful to us to determine the outcomes, but using some methods of statistics we can clearly organize the data, and by organizing it we can analyze it in a more beautiful way. So the definition of statistics would be something like that is it is a science of collecting, organizing, and then analyzing the data. For example, let us consider that there is a medical shop at a place named A who are doing sales of approximately 200 sales per day. So one day what the owners of A thought is that it's time for them to start a new store at another location which is almost let us say 30 kilometers away from A. So they want to start another store named B which will sell the same products. Now they were in a confusion that whether it is better to start B or not, because it will take some amount of money as an investment to start a new store. But at the end what they were achievable, or what they want to achieve is that they want to be profit from this B store. So they will check about all the data, how many people were near the area B and how many people were near the area B out of these 200 peoples. And they will also check that if the store is again kept in second place called B, how many new customers would come there to buy products. So based on all the available data from A store and external data from the location B, they can easily find out that whether it is profitable to start a store at place B or not. If it is profitable, they can start it and they will have two stores A and B which can be profitable. But while doing the statistics, if they feel that it is not necessary or it will not make them profits if they start a store in B, so then they can simply neglect it and they can continue with this A. So this is the use of statistics. Now let us know about the types of statistics. So types of statistics. Basically there are two types of statistics. One is descriptive statistics and second one is inferential. So let us talk about descriptive analysis first. It is the process of taking the already available data and making some more assumptions based on some kind of mathematical calculations based on them. So for example, let us take that we have some data set like x is equal to 1, 2, 3, 4, 5, and then we have some empty value, that means null value. It's not like null value but missing value. So if the data is like this, we can easily fill out the null value or the missing value is using something like mean of these all the 5 data available, or we can use mode or anything. So basically descriptive data is something which is like we are dealing with the data based on some mathematical calculations. We can use different metrics like variance or mean or mode or standard deviation to fill this value. So not only to fill this kind of values, there are similar kind of different available sources or problems which we can solve using this descriptive data. So this is all about descriptive data. Now let's come to inferential data. Inferential data is similar to like we'll have, for example, let us consider that there is a population. So before this population, let us consider that there are going to be elections to be held in a country in 2024. So while elections are going on, there will be some kind of survey agencies who will analyze the data and they will predict who are going to win the elections. For example, if there is some population, let us think that this is the country India. So this is all, consider this is all the population of India. But these survey agencies, while doing the survey, they can't be able to consider all the population of India to do survey. So what they will do, instead they will take some sample amount of data from maybe 1 lakh people or 2 lakh people, and they will make some predictions. So the inferential data or the inferential statistics comes here, where we will have some sample amount of data, and using this sample data we have to predict what is the population data. For example, in sample data we have two parties called, let us say A and B. If A party got 60% votes and B got 40% in their internal survey, and let us suppose take that the sample size is almost 2 lakhs, but the total population of that country who are going to vote is, let us consider that it is 100 crores. So in inferential statistics, our goal is to find that whether this sample data is significantly affecting this population or not. That means whether this sample amount of data will replicate this population or not. Based on that, the survey agencies will give us outcome that this is going to happen. And also I want to tell you one thing, that while they release these surveys, they will tell us that for example, they will divide the voters into categories like teachers, unemployed, farmers, women, and etc. and etc. They will tell that this much amount of people in that country were supporting this government or that opposition party. So they can easily find it using this sample data, and they will try to match it with the population based on inferential statistics. I will discuss this with you in further videos, but as of now, this is the simple explanation of how this will work. So after this, we can go to the next concept called as types of data. So in these types of data, we can basically let what are the types of data available and what are the calculations we can do. So types of data. Before that, we have to understand what is a data. So a data is nothing but set of instructions or facts. So a data is nothing but set of instructions or facts. Now let us understand the types of data. So in types of data, we have majorly two kinds of data. One is quantitative and second one is qualitative. And in this quantitative data, this will deal with numbers, while qualitative data usually deals with categorical values. That means strings. So in this quantitative data also we have further two groups. One is discrete and second one is continuous. So now let us understand about this discrete. Discrete is nothing but having a unique whole number. For example, let us say that number of students or else number of hospitals in the city. So both these will have some unique numbers. For example, let us consider that number of students may be something like 35. Number of hospitals in the city may be like, for example, 115. So what is common in these numbers is these are basically integer numbers, and it is particularly representing a whole number which consists of the number of something unique value. But whereas in continuous, it is not like that. So the best example for continuous is maybe we can take heights of the boys. Heights of the boys are like heights of people, which may be like 175, 173, 180, or even 169.5, 170.2. So what we can observe here is that in this continuous data, we have normal data along with decimal points data. That means continuous data usually deals with the data such as which is not an unique or which may not be a whole number. It can be any number we can deal in continuous data. So whenever they ask you, you have to simply remember that this is discrete variables were usually only integers, whereas in continuous we may encounter float values also. So this is all about quantitative data. Now let us discuss about qualitative data. So now let us discuss about qualitative data. In qualitative, we have two things called as nominal, and second one is ordinal. So the common thing between these two is both will deal with categorical. But what is the difference between these two is nominal data will not have ranks. That means we can't distinguish or sort the data based on a ranking system. That means we can't tell that one category of data is greater than another category of data. For example, we can take some examples like gender or colors. So basically, these two are one of the examples of nominal data. For example, we have a data set called as, for example, we have something like about colors. So I will take first color as pink, and then I'm going to take second color as orange, and maybe I can take the third color as green. So if I give this data to you, and I ask you to make any kind of ranking systems based on the data available, can you make it? No, because these are colors which will not have any impact on the data set, because it's simply not useful what color it is, but the data is important in determining the outcomes, but it will not make any significant changes based on the colors. So these will not have any kind of ranks. Similarly, for gender also we can take male and female. If I ask you to sort based on male and female, can we make it? No, because so while we are making any sorting, we often make them based on something like their college marks or anything else, but we can't make based on male and female. We can't give ranks to them, because, for example, let us consider that there were students in a class and who are boys and girls, so they got some marks in their assessment. So how we will give the ranks for them, based on their marks or based on their gender? It's definitely not based on their gender. So that's why this is a nominal data, which means they will not have any kind of ranks. But whereas coming to the ordinal data, this is also categorical value, but they will have ranks. So here nominal data will not have ranks, whereas ordinal data will have ranks. For example, let us consider that I may take some data like MS, which is Masters, and I may take BTech, and I may take 10th, I may take 12th, and I may take PhD. So this is also same kind of categorical values, same like nominal data, but can you find some difference here? We can sort this data how from lower order to higher order, or from higher order to lower order. This is called as ordinal data. So let us see that how we can sort this data. So if I want to sort this data based on from lower grade to higher grade, I may rank 10th standard as number 1, and 12th as 2, and BTech as 3, and MS as 4, and PhD as 5, because PhD is the greatest of all the above studies above. So this is the ordinal data. The simple difference is that ordinal data will have ranks, where nominal data will not have ranks. So this is the only thing about types of data. In that we have discovered about quantitative data, and this is the qualitative data, in which nominal and ordinal are parts. So now let us see about levels of measurements of data. Levels of measurements. So in this we have 4 subtopics. First one is nominal scale data. Which is similar to this kind of nominal data. That means there will be no ranks, and it is a categorical data. So we can take examples as like gender, color, etc. And we have second type of measurements of data called as ordinal scale data. In which we have discussed previously only. It is also same like that. So we may take here something like classes. which is not the classes in OOPS, but it is like the, for example, like a study classes, which we will study on a regular basis in the world. And we have another data called as interval scale data. So in this interval, we may discuss about few things like it is a numerical. Although it is a numerical, one thing which we can't do here is that we can't measure ratios of two numbers. So the best example for it would be temperatures. For example, let us take that two temperatures like 100 degrees Celsius and 50 degrees Celsius. So first point, these two are numericals and these two don't have, or we can't compare the ratios. So you may have a doubt that why can't we compare the ratios? We can simply do 100 by 50 and we can get something like 2 by 1, right? So you may think that this is about ratio, but here the ratio in the sense means it should be double the. So for example, if I take 50 degrees Celsius and 100 degrees Celsius, there may not be chance that the temperature at 50 degrees Celsius is exactly double the temperature at 100 degrees Celsius, because it is just a measurement of temperature and it will not have any specific proofs or any specific theories that 50 degrees Celsius is the half of 100 degrees Celsius or 100 degrees Celsius is the double of 50 degrees Celsius. It is just a measurement for us which will be given by thermometer to know about the data, but they can't be taken as the ratios. So that's why we can't consider the temperatures examples as ratios. So after interval scale data, we have another type of data called as ratio scaled data. So as the name suggests that we can have ratios here and it should be numerical values. For example, we can take the marks of the students. Like for example, there is a subject called math and 5 students got marks such as 70, 85, 60, 95 and 70. So these are all the data of student 1, student 2, student 3, student 4 and student 5. So if someone asks you to find the ratio of marks between two students S1 and S3, we can simply take these two values 70 by 60 and we can make it as 7:6 ratio. So the marks are distributed between student 1 and student 3 in the ratio 7:6. So this is all about ratio scaled data. So basically in this video, we have learned about what is statistics and types of statistics, types of data and different levels of measurements of data. This is all about today's video, and I'm also going to provide the notes for this lecture on the description of this video. Go there and see and get the notes from there. And also if you like the content, please do subscribe the channel and like the video, and helping me with sharing the video to your friends might also be helpful. And one more thing before I left, I'm going to tell you is that this is my first video in YouTube and I may not convey you in a better way, but please trust me that I'm learning how to do content in a better way and I will try to improve day by day. But I need all your support, so please subscribe the channel and like the video. Thank you all, and Let us meet in another video.